All right, hello everybody again. This is Elo and Goran from Effective TDs, and we just looked at how we can use APFs in thinking particles to avoid objects in a very efficient way by using the APFs. So we basically generate the field of a flow field or a velocity field, and the particles are just being vectored through that field. Now we want to see how we can do this in Houdini and, figure out what are the differences or what are the similarities, and is it kind of also as easy.
My main interest is to see how you do a cross vector in Houdini.
The cross product?
Cross product, sorry, yeah.
Yeah.
Let's see how many
lines of code?
Yeah.
I think we can get through this one without one line of code.
No? You don't need to know C++ or something like that? Or?
No, not really.
Okay, let's see it.
Okay, so do we explain the method again, what we're actually doing? Or
I think that people can check the other.
The
Let's
TP?
do it short.
All right, it's good for the Houdini guys to also check into Houdini, into TP and see how that works. And actually, it's pretty damn good software too. Okay, so the idea is we have particles being emitted on this plane, on this grid here, and they need to move on the x-axis, basically just in a certain direction that we define, which is x in our case, and they should avoid to collide with these circles here, which are, just cylinders, and this is just a grid. So how do we do this? So basically what we did, we created a APF field, which is an all-purpose field, which is just a volume that holds vector data. So to generate a volume that fits perfectly all of these objects, which is was just one geometry, all we have to do is we just type volume, and bam, we have a box.
Wait, it's not the volume.
Why is it not the volume? Maybe we need to create a bound object first. Bounds those.
What's a bound? A boundary?
Yeah, it creates a boundary, and then it is maybe because there we go. We didn't have enough voxels, that's why. So we don't need the bounds. So basically, the volume, when you give it an input, it just gets the boundary of an object and generates voxels. So we'll keep it at 200 by 200 by 200 for now. We could also go by size, and now we get 673 by 100 by 824. So let's just go by unit of 1. So that's a fairly good resolution for a field. Okay, and then we're gonna call this, let's call it val for velocity, and make it a vector field. All right, so as we saw in the TP version, what we need to do is we need, for each voxel, we need to find the closest point of each surface and get the normal of that point. Just to make sure that these points have a normal, I'll just put a normal node here. In Houdini, a normal is just another attribute of a geometry. It does not always get generated by default.
I know.
Yeah, so it's very efficient. Like you can see here how much each geometry that you're looking at, how much memory it costs, or how much disk space it would use to save. And you can also see what attributes it holds. So you see there's a vertex attribute normal and a position for all the points. But if I go here, there's only position points. Okay. So you basically have more control over the data that you're using. Okay, so let's just dive into a volume VOP that we saw before, which basically lets us run through all our voxels. We don't need the density. What we need is to bring in, actually we don't even need the val. All we want to do is we want to overwrite the velocity attribute. So this is going to be our vector. And now we go over every voxel and we get our position. So what we want to do is we're going to get the closest data, which is the geom point or geom particle, whatever it was. So we go x, y, z, distance, and that is basically only giving you the distance. So from the position, give me the distance of this input operated to input. So this is 1, 2, 3, 4.
Okay.
So what we're gonna get is we're gonna get our actual cylinders. And remember, from the cylinders we're generating the volume, we're looping over the voxels of the volume, and the input 2 is gonna give us the original cylinders. So this is the input 2, right? These are our cylinders, our position. And now what this node outputs is the distance, the primitive ID or the primitive number of every single cylinder's primitive. Primitive is like a face in Houdini. When you deal with geometry, like actual objects,
Okay.
a primitive is like a face. And the primitive UV, which is actually a barycentric coordinate.
Okay.
Yeah. So what you do is you go prim attribute, gives you the prim attribute. It wants a primitive ID and the barycentric UV of that primitive, and which is the geometry, the same input. So now we can get any kind of data, which we want is the n for normal.
The XYZ dist will be the geom point in TP that give you the point
Exactly.
position of
Right.
on this object,
Yeah.
and then you get the data from there.
Yeah, exactly. So this is the point. This is the point that extracts the actual
point
data
data.
that you want.
Mhm.
All right, so we want the normal. And now we want to create our 0.3 constant, which is our direction in x. So that was going to be a constant. This is equivalent to
0.3?
Yeah, it just doesn't have inputs. You're giving it the inputs. And we set this to 1. So that is our direction.
You cannot pipe next float on this.
Sorry?
You cannot pipe one value for the I vector.
There is a float to vector. Float to vector. Where is it? Now this is the same as a 0.3. It just
Okay.
doesn't have a vector input.
Oh, okay.
So I could give this a float, set this to 1, put that in here.
Oh, okay.
It's the same
Okay.
simple vector geometry. Okay, so it's 1. And what we wanted to do is we want to cross those two, right? Now something, that is basically how you do a cross product
That's
in
not
Houdini.
so difficult.
It's
Okay.
very easy. What you need to know in Houdini is every time, but literally every time you use a cross product node, just make sure the input vectors are normalized and the output vectors are normalized. Even though you do 2 normalized vectors,
If it's not normalized, what will happen?
it just gives you a skewed result. And this is really like, I've been running into so many times into a problem with this. For this one, we know it's normalized, right? It's a value of 1. We don't have to normalize it. But we definitely need to make sure that this guy is normalized. Okay? And now we just copy this guy, pipe him over. Remember, we switched these inputs because we have to take that this way around. And let's just for now just pipe that in, and also remember, do the normalize. There we go. So now we are having that first step that we had the last time. Now let's just go, just for shits and giggles, let's just create scalar field density and set this to 1. So now we have a density, full density of the whole grid, and we'll just scatter it with points so we can display our vectors. So again, we do a volume trail, get our points and get our vel, and there we go. Every single trail just keeps looping and looping around the objects.
Very nice.
Very cool art, actually.
I like the colors, in fact.
Right. Okay, so we know that that is correct. So what we want to do now is basically based on distance to the surface of each cylinder, we want to blend that to our original vector. So the further away, the more of the original vector, the closest to the surface, the more around the surface to avoid it. Okay, so what we can do is we can grab the distance. We use a fit node, which is our value to value. And the cool thing about Houdini's bops is we can really easy promote the parameter out of this context. So we have control on top of this node, like a black box. So we just middle click it and promote parameter. And then we can call this distance max, for example. Delete this and just set like 15 as a default value, 50 for the range. Okay, and we can run that through a ramp. And a ramp is basically this together, those two nodes together
it's
are
a value to value.
value to value, yeah. You just can also use color, or you can use splines. Here, splines. So now it's a spline. And we'll call this distance fall off. All right. And now let's take this up here, just like here. And we can run this through a color, actually just through a mix. So the mix is our expression that we had. Input 1A, input 2B, and the blend value, right? So the blend value would be this. Input A would be X, input B would be this guy.
It's very cool to see how similar showing that it's with TP. We are doing exactly the same things. We have different names for our
and that's
operators, but it's basically the same.
Yeah, and that's what I love about, like, you know, how people sometimes hate one or the other, and in the end, like behind this, the UI, it's even in this case, even the GUI is the same. There's certain things that work a little bit different behind the curtain, but in the end, if you understand the logic of one software, you understand the logic of the other. This is pretty cool.
That's nice. We cannot do this on TP.
No, well, I just broke it. But yeah, you can do whatever. This is new to Houdini 16. Okay, so now we have a blend value. Just for fun, let's normalize that one as well. In theory, it should equal itself out, but you know, just to make sure. So we're having this normalize this up here. Now we don't need this anymore.
For some reason, looks like your value to value it's not blending correctly.
Yeah, I haven't adjusted it. Okay, so just to understand, so we have the blend. So the 0 value of the distance is gonna be our first input, and the 1 value is gonna be our avoidance input. So what we want to do is we want to invert this with our ramp here. So you saw my ramp that I created inside. I have access to it on the top level, and the distance max I have also access to on the top level, which is really cool. And then I could just modify this whole thing to have no predefined parameters, and now I have like a node with just two things. Yeah. And now we can see that our objects, our particles will avoid. But they will already start before they even get close to the cylinder. And basically there is of course volume data inside the cylinder, but we don't care about that. Okay, so now if we go over, copy our pop from here, and we put that here. So we have our pop net. Let's just call this val field. This is just a Houdini workflow. Like, you create null nodes that you want to reference in another context. You just type in out, and then they're all grouped in a list.
You can create colors on the node.
Yes, you can.
Wow.
You can do whatever you want. You can even give it custom shapes.
I saw that. That's new one, 16, I think. No?
I personally don't like that, but it's yeah, everybody his own thing.
Whatever.
So so we're back in our own original particle system, where we just each point creates one particle at a time on the first frame, and that's it. And then we have a volume VOP to grab those velocities from the one that we created. So if I select this and I go maze, you see we have all the outs grouped, and I can just grab this. And in theory, in here we have a different name. So we just grab this name and look at that. So what the mistake that I'm doing here is I need a scatter on our grid here. Voila. And I need to give them an initial velocity because our volume...
They are outside the volume.
Yeah, the volume is only till here, so they kind of outside. So let's give them a 1.
A little faster, maybe.
Maybe a little bit.
And
okay.
Doing something.
And in TP we were overriding velocity, so we're not adjusting the force. Of course, there's a problem now that we're overriding the velocity. We're not kind of changing the velocity, meaning if the particle is never in the volume, we're just overriding it with 0 because it cannot find it. So we have to either say, are you in the volume, then do it, or well, that's pretty much all we have.
Or you can create your volume bigger.
Right, I could create the volume bigger, or let's see if this guy, no. So let's just make the volume bigger for now. So remember the bound node? It creates a bound, but we can now say, well, get bigger in one side.
Very cool.
And, still not working.
Now you change the velocity.
So that should be working fine. Oh, smart. Okay, and we had a multiplier, promote parameter, call this speed.
Automatically creates connections when you add a node between a line?
Yeah, so if I shake it, I can remove it. If I put it in there, it automatically connects. So now we can use the speed, and let's say 100. Whoa!
Look at that.
Okay, maybe that's a little fast. So it does avoid.
That looks like the curve is inverted, no?
Yeah, you're right. It seems to be inverted based on distance. Or maybe the radius is just too big. Yeah, maybe that's it.
Yeah.
Right. And in this case, let's just set this to 1. So now we're constantly emitting particles. And maybe a little less. That's a little bit tricky in Houdini. You constantly have to jump between levels because in this case, we're emitting points from scatter. Let's just go inside here and now set that back to surface. And now we can say how many particles per frame. There you go. And again, it's really fast because that field gets just generated once and all the particles
follow these velocities.
Exactly. So very similar setup, very effective. I think it's very powerful. And in both softwares, same workflow.
You can see that obviously there is the difference of the UI and how you jump in Houdini back and forth to enter. But we saw that to generate the field itself, it was almost like side-by-side identical.
Right. And I mean, I don't know, I think it's so fast. Like once you know one software and you're familiar with both UIs, you can just keep using the same same logic, same ideas. So yeah, one thing in Houdini when you work with particles or any DOPs, by default they're kind of caching. So you see this blue line. Basically that means once it's cached, it's real time. It reads it from memory, and you see here it gets slower. So this is really cool when you're like when you let it cache, but then you can just preview it in real time.
How do you refresh now this cache?
So if you want to refresh it, you can reset simulation, or you just change something, like for example.
Automatically within
yeah, you see it immediately change, but it doesn't go back and reset it. You have to just rewind.
Okay.
And then it does it. Yeah.
Very cool.
I think pretty powerful. I think we can see here that this velocity override is slightly different than the one in TP. These ones are much more precise, while the TP one was pushing all the way, right?
Yeah.
So maybe the TP one does something like this internally. So it goes like this, mix, and then it needs to go like this, and then it says 0.5 in this case, so it's going to take 0.5 of the original one and 0.5 of the new one.
Yeah,
and then you can
I realized that it kind of blends in some way even using.
Yeah, so you see now it's much softer in terms of following the exact thing, and you see it kind of, well, we didn't get this effect in TP though.
It's very interesting though.
Yeah, so you have full freedom of doing whatever you want, but it's cool.
So yeah, IPF, we show a little how to work with it. There is much more other things that we can do with IPF.
Yeah, I think the whole field of fields of volumes.
Yeah.
It's just like you have so many more possibilities and to use it in any different ways. It's insane. Also, I think what is really cool here is right now we're generating a giant volume around all the objects, but we could actually generate just an SDF field that is based, just around each object, and then particles. We could have a condition that says only if you're inside one of those volumes, then start following these rules, and you would end up with much less voxels, which increase your speed for simulation. So yeah, it's just the possibilities are literally endless.
And we are not doing it, but we can set up these as forces, and then we can mix it with fluids or a bullet or whatever.
Exactly.
We can do so many things.
Right.
We are using it a lot in production now with flow simply as a boundary.
With the TP flow?
Yes, we use TP flow with...
for collisions.
For collisions, only for collisions. Because we had a boundary in flow, but this is based on a ray intersect. So we run into some problems about accuracy, and now with the IPF there is no problem. Plus it can work with the deforming mesh without any problem.
Oh really? And how does it deal with when you have a deforming mesh, let's say a character that is running and his arm is moving really fast? Does the SDF get that velocity inheritance of the arm or whatever the character is doing, like the deformation velocity? Because that is one problem that is really tricky to handle, is like collisions with SDFs, they get the direction away from the surface, but then you need to add the velocity of that point of surface as well to that direction.
I think, basically you will need to do that. I think that you can do it, but by default it
disregards the velocities. Yeah. Okay.
Yeah, it's simply a collision, but it works way better than before.
Right.
And it's simply...
it's the same idea, right? It's like if you're in the voxel that has this vector, just follow that vector. Don't care. Like each particle just reads up one value. It doesn't have to recalculate for every particle.
Exactly. And we can work with we have characters with millions and millions of polys and doesn't care.
Right.
It creates the field with BDB super fast, a resolution of how much resolution do you want, and it's simply then you can have as many particles as you want interacting with this BDB super fast.
Where's the distance here?
Okay, so maybe we wrap it up.
Yeah, I'm just enjoying playing with this thing.
It's so fun when things are fast to keep.
It's true. Why is this?
I like a lot to play in real time.
Yeah. Yeah, that's really nice in TP. Like you can just scrub stuff and it keeps re-updating always from scratch. It can be of advantage sometimes. Also, one thing that I really miss from TP is like every time in Houdini that I change a value, for example, 1, it jumps out and I have to click again and do. I cannot just like say 1, 2, 3, 4 and then just find the number. I always have to click. Yeah, maybe there is a setting for that, but I haven't found it yet. All right.
Okay, cool.
I think that was pretty cool. That was pretty cool Saturday session. I hope you guys like the APFs and the volume fields and show us what you guys do with it, and we will explore more ideas and maybe do more.
You can show your advance in APF on the forum. Remember that we have an effectivetds.com/forum. Please add whatever examples you come with, and we can discuss.
Or if you have any questions, we're there to help in both Houdini and Max. And in my opinion, it doesn't matter what you use. We're all doing effects here, and both softwares are amazing. And each one has its strengths and weaknesses, so it'd be really cool to see people start using both and excel even more through that. All right, well that was awesome. See you guys next time.
See you.